review sheet. I will do some of them with you, leave some of them for the rest of you to do. And then the second thing is I'm going to call you up one by one. We're going to have a quick desk side chat about what you did, tuck in your shirt, what you did during e-learning and or what you didn't do during e-learning. Hey, I gotta talk about the 800-pound gorilla in the class. Hey, obviously I have no control when you're at home, right? I can only trust that you are a good moral citizen and you do the right thing. When people turn in tests and the only thing there are answers.
I'm here if you can hear me.
Right, I can hear you. When people turn in tests and all there are answers and they are the correct answers, I mean, come on, right? If there's no work, right, and it's a problem that involves 8 steps and they're all complicated and you just turn in answers, and it was a couple people in this class, I can only suspect one thing is that one that you just went online and you had a computer do it for you, which in today's world, it's very easy to do. I mean, I know what photomath is. I know what Desmos is. You just hold your camera up to the thing and it does all the math for you. And it shows you all the steps too. So if you were dumb enough not to write the steps down and you only wrote the answers, I mean, I know what was going on, especially from the people that were struggling all through. I have no control over that, right? I can't stop you from doing that because I'm not there with you. I can stop it when you're in my class. It's all fine because we're going to take a semester final and you will be in the class when you take that. So if you chose to not do the correct thing, then it will all come to pass, or the bill for that cheating will come to pay when we get to the test day. I don't need to answer questions on any of that. Most of you did fine. I saw your work. In the grand scheme of things, we're about where I would see most classes. We got kids that are kicking butt and taking names in this class, right? And we got kids that are struggling mightily in the class. As long as you're trying, I can promise you that this will turn out well. It's the kids that aren't trying, the ones that I can't reach, right? The ones that are like, I'm just going to show up to class, I'm not going to pay attention, not going to work. Those are the ones that concern me. But if you're trying, trust me when I say you'll get this, because every single day we'll do work on this. All right, let's take a look at what's in front of us. This is kind of easy skills, but some of them are a bit more challenging than others. So we basically have only learned 2 things so far in this chapter. We've learned how to reduce a fraction and how to multiply with fractions. The big difference is now we have polynomials. That's the only difference between this and, say, pre-algebra, is that we got polynomials. So, for instance, on question number 1, everybody look at question number 1. When it says reduce, well, you gotta factor. So it's the F word here. We got to factor. So if we factor this first one, what we're really looking at is the numerator all by itself and the denominator all by itself, one at a time. So big, long fraction bar. If I look at the bottom, the numerator, p minus 7, does anything go into p and negative 7 other than 1? No. So you can't factor that, so it's just p minus 7. So p minus 7 doesn't, I can't factor it. The top one, does anything go into 10p and 70? 7 doesn't go into 10, but it does go into 70. 10. Notice 10 goes into both terms, 10p and 70. So I write a 10, because that's what I'm factoring out. That's what I'm dividing out of both terms. And remember, we're just doing the distributive property reverse here. I put parentheses. 10 goes into 10p. And then what times 10 is 10p? P, right? 10 times p is 10p. I can think of this as 2 ways. I either think of it through multiplication, what times 10 is 10p, p, or 10p divided by 10 is p. You can either think about it as multiplication or division. Either one works.
I thought that we were supposed to do this thing where it's like the top minus the bottom.
Well, that's the next thing we're going to do. What times 10 is negative 70? Not 7, negative 7. Now we're going to do the thing that Joe's was. So now we've factored it both. Now we can do some canceling. Notice I got a p minus 7 on the top, and I got a p minus 7 on the bottom, and there's multiplication involved, so I can cancel. Therefore, you're left with, after the canceling is over, 8 and y when I look out upon the sea of faces there, yours is the one that's turned around your desk, not doing the work. Okay. So the answer is 10. So this is, I would say, an easy factoring one.
How does it equal 10 if on the answer review thing, on like the worksheet, it's, the answer part, it says 10, 7?
What? Ah, because this actually has two parts to it, right? So this was just part one, which is factor it or simplify it. Step number 2 says the following. I don't have the instruction here. It says, are there any excluded numbers that can't work with this problem? So the excluded values, we only look at the denominator. And we say, remember, we can never have a 0 in the denominator. What would p have to be in order for the denominator to turn into a 0? Turn into a 7. Now, this is an easy one. There's no work involved. You just kind of look at it. But the work really involves this. You take the denominator and you set it equal to 0 and you solve for p. And that will be the number that p cannot be. So add 7 to both sides, you get 7. If p was 7, 7 minus 7 was 0. Okay? So we're not claiming what the answer is. We're just saying that it can't be the number 7. Notice there is no equal sign to start with. So this is why we're not solving this equation. We're just saying, what does this reduce to? The whole fraction reduces to the number 10, semicolon, and p, put an equal sign with a slash through it. That means does not equal, and p cannot equal 7. I'm writing with my finger here. That's why this looks horrible. Okay. So that's how these are doing. We're going to do a bunch of these. All right, as many as you want.
Yeah, number 2.
All right, well, when do we want to do now?
I mean, number 3.
Number 2 is a good one. Let's do number 2. All right. It kind of has that same flavor as the previous one. Notice that the only thing on the bottom is n plus 6. That can't be factored. There's nothing that goes into n plus 6 other than 1 or negative 1. But the top can be factored. Notice that both terms have an n, so I can factor out an n. And what goes into 9 and 54? Okay, so I'm going to factor out a 9 and an n. Why an n? Because there's an n in both of them. What times 9n is 9n squared? How about n? 9n times n is 9n squared. 9n times n. If you want to think about it as division, divide 9n squared by 9. So in my head over here, this is what I'm thinking of. If I had 9n squared on the top, and I divided it by 9n, the 9's would cancel. There's 2 n's on the top, 1 on the bottom. We left with 1 n on the top. That's why the answer is n. What times 9n is 54n? Plus 6. Okay, everybody good so far?
Yeah.
All right, then we can see that the n plus 6's cancel, and you're just left with, and that is the simplified form. Now we just got to figure out what's excluded. Negative 6, right? In other words, if we set n plus 6 equal to 0, by the way, just so you know, our book does it for this one section and forgets about it for the rest of the book. And you never see it again until pre-calculus, maybe Algebra 2. But our book ignores this excluded values except for this one section. It's a pretty important thing, but our book says, we'll come back to that in a couple years. Won't see it in geometry next year. You won't see it, I don't think you do it in Algebra 2, but you certainly do it in pre-calculus. Yeah. Well, let's finish this one. So you'd set n plus 6 equal to 0, and you solve, you subtract 6 from both sides. So we get n is equal to negative 6, but that's what 6 cannot be. 6 can't be a negative 6. And you're like, why would I do all that work? Can't I just look at it and say n can't be? Yeah, you can do that as well, too. Okay. All right. Rylan wants us, are we good on this one?
Yes.
Rylan wants to look at number 3. All right, number 3 is the first tough one. Why is this one tough? You got a quadratic trinomial. That means you got to factor it. Every one that I gave you that was a quadratic trinomial, bottom denominator, 3 things, trinomial, to the second power or a quadratic. Notice on the previous one, we had a quadratic, but when we factored out an n from it, it went away and turned into just a linear times a linear. On this one, though, our denominator can be factored fully using the stuff from the previous chapter. This one's kind of the opposite of the other one. This one, well, the top can't be factored. It's just n plus 3. But the bottom one, if it is factorable, we're looking for two numbers multiplied -27 that add up to -6.
Oh,
So let's think. 1 and 27, that doesn't work. 2 doesn't go to 20. 3n. Can you use a 3 and a 9 and get back to a 6?
-3 and plus
She said -3 and plus 9. Do you agree or disagree?
9. I agree.
You see the negative right here?
Oh,
So it's -9 and a +3. Because -9 plus 3 is -6.
oh,
So this one would turn into n plus 3 and n minus 9. And this is where, mark this date on the calendar, this is where the people that are only slightly paying attention get completely lost and have no chance the rest of Algebra 1. The people that are paying attention are like, yeah, bring it on. I got this stuff. It's easy. Right? If you only pay a little bit of attention, you won't get this. You got to stay focused for the class. Because the kids that just said, oh, yeah, got it, they do have it. They really do. And they can see that. But for the kids who are like, I don't know, I'm just hearing noises. Right? Those are the kids that will, I mean, really, this is where math for you for the rest of your life goes downhill. You got to stay with it. It's not that much more difficult, but it does require a bit more attention than normal. All right, anyone lost where I got n plus 3 on the top? I didn't do anything. But on the bottom, n plus 3, n minus 9. The ones that I put on the test will be as easy as this. The ones where it's a is equal to 1 and it's really this complicated one, I'm not going to put those on a test until Algebra 2. Algebra 2 is when we'll see this again, and we'll start doing the more complicated ones usually. But for Algebra 1, we've got over the hump of the more challenging ones. For factoring, we're just going to factor the easy ones. Oh, by the way, what cancels here? Okay, so what are you left with? Yeah, but it's on the bottom, so it's not n minus 9, it's 1 over n minus 9. Well, remember, you see on the top, the n plus 3 cancels? Well, this slash really means 1. We just choose sometimes not to write that 1. In this case, since that slash went through all of the n plus 3 on the top, you got to put something, you can't put 0, so you're left with 1. Oh, but boy, does this one get ugly now. Because remember, to find what the excluded numbers are, we got to consider the denominator. So in factored form, remember that turned into n plus 3. You do. And n minus 9. Those both we will set equal to 0 and solve. I'm saying, most people at this stage that have been paying attention, they're already jumping to an answer and they're telling me shortcuts, and the rest of the people are like, what is going on? Well, no, because that's just the start. Remember, this is what has to equal 0 to tell us what it can't be. Hey, this is that zero product property. Something times something equals 0. That either means this thing is 0, this thing is 0, they're both 0. Sierra's already like 40 steps ahead of us, and she's already got the answer because she knows, she's seen this story over and over again. But for the rest of us, we got to set each one equal to 0. So I said n plus 3 equal to 0 and solve. Well, that's going to give me -3. We set the second one equal to 0, n minus 9 equal to 0. Well, that equals +9. And what Sierra said, oh, this is one of those ones where it's just the opposite of what you wrote, because she's seen that pattern before. Yeah, she's right. It's -3, +9 are the excluded. So the excluded, what n cannot be, are -3 and a +9. If n were a -3 or +9, it would turn the whole darn bottom thing into a 0, which we can't have. That's a lot of work. That's as complicated as this gets for simplifying a fraction. So how many of these would I put on the test? 1. Oh, but we're way far away from having a test, but just so you know. Most of the ones will look like, we'll do one more and call it a day for this. Most of the ones will look more like, like something like this. There is, but I want to give you ones that you can look at all by yourself, right? Most of the ones that we're going to do are going to look like something like this. Hey, just simplify this fraction. All right. So we draw a fraction bar. Well, 80 is just 80. There's nothing to do there to factor on the top. But in the bottom, Julie, what goes into 20R and 50? What goes into 20R and 50? So I'm going to write a 10, and you're going to tell me what goes on the inside of the parentheses. So far, so good. What goes on the inside of the parentheses? There's definitely going to be an R. So 10 times R is 20R. Ten times R has to equal this number. Well, 10 times R is not 20R, so what does it have to be? 2R. So 10 times 2R, 20R. What goes the next number? We're trying to get to this number. Positive or negative? Because 10 times negative 5 is positive 50. So what? Positive 5. So plus 5. And my handwriting's horrible. I apologize. Ugh. Wait a minute. The previous one, we got the same thing, like an R plus 3 and R plus 3. This time we don't. So this, you just got to be thinking ahead. We've got an 80 on the top. We've got a 10 on the bottom. Think about that as a fraction all by itself. 80 over 10 would reduce to 8 over 1. So this whole thing right here just refers to 8. I can put the 1 if I want, but really 1 times 2R plus 5 is 2R plus 5. So this turns into 8 over 2R plus 5. This is absolutely 100% one like, I'll give you 2 or 3 of these on a test. If you know what you're doing, this is easy, easy money. If you don't know what you're doing, it's hard. By the way, that's only half of the problem. The other half is excluded values. To find the excluded value, we look at the entire denominator and set it equal to 0. Unless it's a number, a whole number. Like if it's 40, there's no excluded numbers. There's a couple here that have no excluded numbers. And that's when there's no variable in the denominator. So we take 20R plus 50. We set that equal to 0 and solve. Subtract 50 from both sides. We get 20R is equal to negative 50. Divide both sides by 20. And then reduce. Then we get what? Negative 5 over negative 5 halves. So the excluded value is negative 5 halves. That is the excluded value. So the answer is 8 over 2R plus 5 with the excluded value of negative 5 halves. Where did I get the negative 5 halves from? Negative 50 over 20 reduces to negative 5 over 2. Okay. That was questions what? Yeah. So it would be 2 times 3x minus 2. 2. All right. What's the next section? Is it multiplication? It is. All right. Next section starts at question number 11. Let's take a look at that. I gave you plenty of practice here, probably more than is necessary, but more is better than fewer. 9 was the only other one. By the way, who's got the factoring real quick? 42, that adds up to negative 13. 7 and 6, you got it. So minus 7, minus 6. All right, not to insult your intelligence, there's 2 ways of doing these. You can either do cross reduction first, or you can multiply cross and then reduce. Which one do you want to do? Cross reduction is always the quickest. Unfortunately, for number 11, there's nothing to cross reduce. You can do the 2 and 8, right? There's no cross reduction, but 8 over 2 you can reduce, which is 4. So if I turn that into a 4, I mean, technically that's just reducing the first fraction. It's not cross reduction. 4x times 5 is 20. And then on the bottom, we're left with, boy, that was simple. If you reduce first, there's no more reducing to do ever. You can, right? Just remember the bases have to be the same. Right, and there will be some like that. So for instance, he wants to do number 12. Okay. Cross reduction, well, nothing with the numbers, but the r's, right? You got an r squared here, you got an r squared here, they would cancel. Why do they cancel? Because remember, you'd have an r squared over r squared if you multiplied straight across. So they both cancel, and then you multiply straight across, easy peasy right here. 2r times 8, careful, 16, and then on the bottom, 60. There you go. Julie, you want to do one? All right, let's do 13. All right. So cross reduction, 7 and 5, no. 6 and 9, yes. What goes into 6 and 9? 3. So 3 goes into 6, and 3 goes into 9. And you can see the problem with cross reduction is it's just messy, right? So your question, if both A's are on the bottom, does anything cancel? Nope. Nothing cancels. So, and on top, what? What? On the top? There isn't. I'm saying the top turns into, thank you, Julie, saved the rest. Where are you guys getting 35 from?
I did 7 times 5.
Those aren't at the top. On the bottom, okay, we got a problem. 3 times 5, that's easy. That's 15. But what's a times a squared? All right, Tristan's got it. Remember, when you multiply common bases, you add the exponents. 1 plus 2 is 3.
But is doing like all straight across easier?
So for me, when I'm doing it, whenever I get a problem like this, I just, because I got horrible handwriting, I just tell myself I got to slow down. I got to write nice and neat and try to be careful. I'm always cross reduction because you deal with smaller numbers to multiply. And then even in the reducing part, you're going to be dealing with such large numbers, it's easier to make a mistake. I'm all about cross reduction first. All right, somebody pick another one that you think is hard.
17.
17, nothing reduces.
Oh, 16 then.
Number what? We're doing the multiplication ones.
16, I guess. Yeah.
All right, 16's got a lot of cross reduction. All right, yeah, this is a good one. 16. Well, can everyone see that the 9s cancel immediately? I got an X on the bottom. I got an X on the top.
X squared.
I got an X on the bottom. And that 4 is going to turn. Boy, this is messy, messy, messy. Anything else reduce? No. So we multiply straight across. We still have this 3 right here, though. So, yeah, but all the X's on the top got canceled. So 3 over 2, and that was X to the 3rd. Ugh. I know. I need a stylus with a pad or something.
Old math teacher had. He had like an iPad. He would like get one of those Apple iPads and he'd like write something.
Yeah. Well, I mean, normally what I do is I already have all this worked out for you, and I do it in PowerPoint. I think it's even nicer that way, but. Yeah. All right, last call. Any other ones you want to try? 19? All right, 19. All right, since Aiden spoke, you're going to do it, Aiden. All right. Anything cross-cancel, Aiden? What about the 8 and the 10? So what goes into 8 and 10? 2 goes into 8 how many times? 2 goes into 10 how many times? This is a good one, Aiden. Guess guess why? I can't talk. There's a 5 on the top and the 5 on the bottom. It's a double cancellation. But you didn't see that from the very start. So that cancels and that cancels. All right, what's left that I haven't drawn through? So on the top, what are you left with? On the bottom, what are you left with? And you got it right. Agreed. Well, I don't know if you remember how I started class a couple, when we started, as I said that typically when you do fractions, the first thing they have you do is add, subtract, and then multiply and divide. This one we'll do division tomorrow. We save adding, subtracting for the very end because adding, subtracting is the biggest, messiest thing that we'll do the entire year.
So number 20, nothing fractions.
All right, let me catch up. All right, number 20. Go away. There we go. All right, number 20.
Nothing cancels.
You got a 9 and a 9. 9 and a 9. And that's it. So what are you left with? And you're done.
I got this.
All right. Here's what we'll do the remainder of the time. So I'm going to call you up one at a time. Keep working on the worksheet. We'll look at what you did during e-learning. I'll show you what you're missing. And thank you. Here, one of those.
Can I sit here?
Sure.
How much more minutes into the class?
15 or so. All right. Any other last questions? Always. Say again? That's the final answer. And just remember, the answers are on the back too. All right, e-learners, any questions?
No, none at all.
No question.
All right.